Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. This video will once again cover the topic of VLANs. Although we've already covered the most important basics about VLANs, there are still a few more things you should know about VLANs for your CCNA. This is going to be a long video again, so let's get right into it. First off, here are the topics that will be covered in this video. First off, a little addition to the previous video. I will show you how to use the concept of a native VLAN on a router when using router on a stick for inter-VLAN routing. Next up, we will look at a few Wireshark captures to see the .1q tag. Wireshark is a great tool for network engineers, so I plan to use it at various points in this series to help you understand these topics. After that, we'll look at the final method of inter-VLAN routing, which is layer 3 switching, also known as multilayer switching. I've always told you that switches are layer 2 devices, and don't use IP addresses. However, many modern switches are actually layer 3 capable as well, and I'll talk about that in today's video. Next up are two topics which have actually been removed from the CCNA exam topics list: DTP, the Dynamic Trunking Protocol, and VTP, VLAN Trunking Protocol. I was planning to cover these in this video, but due to the length of the video, I'll reserve a separate video for them. Although these both have been removed from the exam topics list, I think it will probably be important for you to understand these topics at least at a basic level for your CCNA, and you may actually see some questions about them in your exam, even though they have been removed from the topics list. However, I will give just a basic overview of each. There is no need to go in depth. Before getting started, I want to say make sure that you stick around to the end of today's quiz. From now on, I'll be featuring one bonus question from Boson ExSim, Boson's set of practice exams for the CCNA. Look forward to that. If you want to get a copy of Boson ExSim for yourself, by the way, follow the link in the video description. No other practice exams help you get ready for the real exam like Boson ExSim. So if you can, I highly recommend getting and using it to prepare for your exam. So let's move on to the first point, using the native VLAN feature on a router. I said in the previous lecture video that the best practice is to set the native VLAN to an unused VLAN, as the native VLAN feature can cause some security issues. I will talk more about network security later in the course, by the way. However, if you want to use the native VLAN feature, let's see how to use it on a router. The native VLAN feature does have one benefit. Because frames in the native VLAN aren't tagged, it's more efficient. Each frame is smaller, so it allows the device to send more frames per second. In the previous video, I set the native VLAN to 1001 on switch 1's G00 interface, and switch 2's G00 and G01 interfaces. So just for this demonstration, let's set them back to a used VLAN, VLAN 10 on all trunks. There are two methods of configuring the native VLAN on a router. Let's take a quick look at both. First up, you can use the command encapsulation.1q, followed by the VLAN ID, followed by native. This tells the router that this subinterface belongs to the native VLAN, and it will function just like the native VLAN on a switch. It will assume untagged frames belong to the native VLAN, and frames sent in the native VLAN will not be tagged. The second option is to not use a subinterface at all, but just configure the IP address for the native VLAN on the physical interface of the router. The encapsulation.1q command is not necessary in this case. Okay, let's look at each option. First, I will configure the first option. Here it is. On the G00.10 interface, I configured encapsulation.1q10 native. Note that this is the complete topology from the previous lecture video, so the IP address is already configured. The only change is that I added native to the encapsulation.1q command. Let's take this opportunity to look at a Wireshark capture to demonstrate the native VLAN. This PC in VLAN 20 has an IP address of 192.168.1.65, and this PC in VLAN 10 has an IP address of 192.168.1.1. I will use Wireshark to monitor this connection between R1 and switch 2. Wireshark will capture all frames on this connection in both directions, so we can take a look at what traffic is passing through. Let's send that ping. We will first look at the capture of the ICMP echo request message as it goes from switch 2 to R1. It will be in VLAN 20, and it's being sent to R1 for inter-VLAN routing. Here's the Wireshark capture for the ICMP echo request as it goes from switch 2 to R1. First off, you can see the source and destination IP addresses here. Now let's look at the Ethernet header encapsulating the IP packet. Specifically, look here. Type 802.1q virtual LAN, and notice the hexadecimal 8100 value here. I said in the previous video that .1q is inserted after the source MAC address field, and that is where the type field usually goes. This here is the TPID field of the .1q tag. Under it, these are the rest of the fields of the 802.1q tag. First is the PCP, priority code point. It has a value of 0, so no special priority is given to this frame. Under it is the DEI, drop eligible indicator. Again, a value of 0, so it won't be dropped during times of network congestion. Next is the most important field, the VLAN ID, which is 20, as you would expect. The PC that sent the ping is in VLAN 20, and it's not the native VLAN, so that's why this frame is tagged. Finally, under that is the normal type field of the Ethernet header, indicating that an IPv4 packet is encapsulated. It normally comes after the source MAC address field, but now the .1q tag is between them. Next, let's look at the ICMP echo request going from R1 back to switch 2. It will now be in VLAN 10, because the destination is in VLAN 10. VLAN 10 is configured as the native VLAN on both R1 and switch 2. So let's see what's different. Here's the exact same ICMP echo request, the exact same layer 3 packet, as it is sent from R1 to switch 2. What's different? It is being encapsulated with a new Ethernet header, but this Ethernet header doesn't have a .1q tag. This is the native VLAN function at work. Both R1 and switch 2 understand that untagged frames belong to VLAN 10, so there is no need to tag each frame with .1q. That ICMP echo request will continue to the destination, untagged all the way because VLAN 10 is configured as the native VLAN on all devices. When this PC in VLAN 10 sends the ICMP echo reply, it will be untagged until it reaches R1, which will then tag it in VLAN 20 and send it back to the PC that sent the request. Now let's take a look at the second method of configuring the native VLAN on a router, which is simply configuring the IP address on the router's physical interface. No need for a subinterface or the encapsulation.1q command. Here is how to configure it. First, I used no interface g00.10. This deletes the subinterface. Then I entered interface configuration mode from G00 and simply configured the appropriate IP address on the interface. To help you visualize it, here is the output of show running config for G00 and its subinterfaces. First off, these commands here on the physical interface are there by default. I didn't configure them. The physical interface is configured normally with an IP address. This will be used for the native VLAN, VLAN 10. The other subinterfaces are just like we configured them in the previous video, with the encapsulation.1q command and their own IP address. This will function just like the first option we saw. Switch 2 will send VLAN 10 packets in untagged frames to R1, and R1 will send them in untagged frames also. As I said before, it is recommended that you just change the native VLAN to an unused VLAN for security purposes. But if you want to use the native VLAN, it's important to know how to do it on a router, so these are two methods you can use. You might also need to know this for your exam, by the way. Here's the network diagram once again. We have one router and two switches. Or I should say, two layer 2 switches. This is the icon we've been using for regular layer 2 switches. But let me introduce you to another type of switch. This is the icon I will use for what is called a layer 3 switch. also known as a multi-layer switch. From now on, I will use either term, layer 3 switch or multi-layer switch. You should know both. By the way, these are the official Cisco icons for a layer 2 switch and a layer 3 switch, but I think the ones I use in my videos look cleaner and more modern. First, let's review exactly what a multi-layer switch does. A multi-layer switch is capable of both switching and routing. It is layer 3 aware. A regular layer 2 switch is not layer 3 aware. It doesn't think at all about IP addresses or anything above layer 2. It only cares about layer 2 information like MAC addresses. You can assign IP addresses to its interfaces like a router. Previously, we haven't assigned any IP addresses to switches, only routers. With a layer 3 switch, you can configure routed ports, which function like an interface on a router. Not just physical interfaces, but you can also create virtual interfaces for each VLAN, and assign IP addresses to those interfaces. These are not separate physical interfaces, but virtual interfaces in the software of the switch that can be used to route traffic at layer 3. You can configure routes, like static routes, on a multi-layer switch, just like a router. Finally, it can be used for inter-VLAN routing. So far, we have looked at two methods of inter-VLAN routing. The first one in day 16's video was using one connection for each VLAN between the router and switch. This works, but if you have many VLANs, you probably won't have enough interfaces on your router. The second method was router on a stick, which uses a single trunk connection, which carries traffic from all VLANs between the switch and router for inter-VLAN routing. This is efficient in terms of the number of interfaces, just one, but in a busy network, all of the traffic going to the router and back to the switch can cause network congestion. So in large networks, a multi-layer switch is the preferred method of inter-VLAN routing. Let's see how it works. Here is the topology again. Now let's replace switch 2 with a multi-layer switch. There we go. And now let's make one more change. I've replaced the trunk link between switch 2 and R1 with a point-to-point layer 3 link. We will no longer run VLANs across this. I'll talk about this link later and assign IP addresses to R1's G00 interface and switch 2's G01 interface. But for now, let's focus on the inter-VLAN routing done on switch 2. For review, when we used router on a stick for inter-VLAN routing, traffic being routed between VLANs was sent to R1 first, and then sent back to switch 2, and then forwarded to the destination. For example, if this PC in VLAN 20 wants to ping this PC in VLAN 10, the traffic would follow a path like this. From the PC to switch 2, from switch 2 to R1, tagged in VLAN 20, from R1 to switch 2, tagged in VLAN 10, from switch 2 to switch 1, tagged in VLAN 10, and finally to the destination. However, switch 2 is a multi-layer switch. It doesn't have to send the traffic to R1 for inter-VLAN routing. It can do that with something called switch virtual interfaces. SVIs, or switch virtual interfaces, are the virtual interfaces you can assign IP addresses to in a multi-layer switch. Configure each PC to use the SVI, not the router, as their gateway address. When using router on a stick, the router was used as the PC's gateway. This time we will use the switch's SVIs instead. To send traffic to different subnets or VLANs, the PCs will send traffic to the switch, and the switch will route the traffic. These are the SVIs I configured on switch 2. These are the same IP addresses I configured on R1 when doing router on a stick, the last usable IP address in each subnet. So these are already configured on each PC as their gateway addresses, so there's no need to change the PC configurations. Now let's take a look at the path the traffic between these two PCs takes this time. The frame arrives at switch 2. The destination is in the 192.168.1.0/26 subnet. Switch 2 now has its own routing table, so it looks up the destination in the routing table, and sees that the destination is connected to its VLAN 10 SVI. So the traffic is now routed to VLAN 10. If switch 2 doesn't have the destination MAC address in its MAC address table, it will flood the frame to all VLAN 10 interfaces. But let's assume it has already learned the MAC address. So it forwards it to switch 1 over its trunk interface, tagged as VLAN 10. Switch 1 then forwards it to the destination. Now, what if the hosts want to reach destinations outside of the LAN? For example, I've added a cloud connected to R1 to represent the internet. Because switch 2 is their default gateway, any packets destined outside of their subnet will be sent to switch 2. But our previous router on a stick configurations for the connection between switch 2 and R1 will no longer work. In addition to configuring virtual interfaces, SVIs on multilayer switches, we can also configure their physical interfaces to operate like a router interface, rather than a switch port. So we can assign the subnet 192.168.1.192/30 for this point-to-point link between switch 2 and R1, with switch 2's G01 interface having an IP address of 192.168.1.193, and R1's G00 interface having an IP address of 192.168.1.194. Then we configure a default route on switch 2, pointing toward R1, so all traffic destined outside of the LAN will be sent to R1. I already covered static routes, including default routes, in previous videos, so I won't explain the concept in depth again, but I will show you the configurations once more. So let's do that. Let's get into the configurations, starting first with the point-to-point link between switch 2 and R1, and then the SVIs on switch 2. First off, remove R1's router on a stick configurations, and configure that new IP address on G00. First off, I delete each subinterface with this command: no interface G00.10, .20, and .30. Then I use the command default interface G00 to reset G00 to its default settings. After that, I used show IP interface brief to check the interfaces. Notice the status of the subinterfaces. It says deleted. Although we have successfully deleted the subinterfaces, they will remain here with a deleted status unless we reload the router. That's no problem though, so I'll just leave them. Then I simply enter interface configuration mode for G00 and configure the new IP address with a /30 subnet mask. I use show IP interface brief again, and you can see that the new IP address has been successfully configured. Now let's look at the switches side of the point-to-point connection. First, I reset the G01 interface to its default settings with the default interface command, because it was configured as a trunk for router on a stick because of the previous lab. Next up is a very important command, one you must not forget: IP routing. This command enables layer 3 routing on the switch. It lets it build its own routing table, like a router. If you forget this command, your inter-VLAN routing will not work. Next up is another important command: no switch port on the interface. This is the command that changes the interface from a layer 2 switch port to a layer 3 routed port. Now you will be able to assign an IP address to it. So, I assigned 192.168.1.193/30 and used show IP interface brief, and as you can see, the IP address is assigned to it just like a router interface. Last up is the default route pointing to R1. As I've already shown you in a previous video, the command is IP route o.o.o.o, o.o.o.o, followed by the next hop, in this case 192.168.1.194, which is R1. I then used show IP route to confirm, and you can see that switch 2 now has a routing table, with a default route pointing to R1, and connected and local routes for the routed interface we configured. And one additional command you can use to confirm is show interfaces status, which I showed in a previous video on Ethernet switching. Notice that in the VLAN column, instead of a VLAN number, G01 displays routed. Okay, now let's move on to configure those SVIs on switch 2. SVI configuration is very simple. Here are the configurations for switch 2. Use the command interface VLAN 10, for example, to create an SVI for VLAN 10 and configure it. Then assign an IP address, and use no shutdown to enable it. SVIs are shut down by default, so remember to use the no shutdown command to enable them. I repeated the process for VLAN 20 and VLAN 30, and that's all there is to configuring SVIs. Very simple. Now, just to demonstrate one problem you might encounter, I created another SVI for a VLAN that doesn't exist on the switch, VLAN 40, and assigned an IP address, 40.40.40.40/24. I also made sure to enable it with no shutdown. However, look at the SVI itself. It is down, down. Why is that? Well, it's because the VLAN doesn't exist on the switch. Let's take a look at the conditions required for an SVI to be up, up. First, the VLAN must exist on the switch. In this case, we haven't created VLAN 40 on the switch, so the SVI won't become up, up. When you assign an access port to a VLAN, if the VLAN doesn't yet exist on the switch will automatically create the VLAN. However, if you create an SVI for a VLAN that doesn't exist yet, the switch will not automatically create the VLAN. Second, the switch must have at least one access port in the VLAN in an up-up state, and or one trunk port that allows the VLAN that is in an up-up state. For example, in the topology we're using here, Switch 2 has hosts connected in VLAN 10 and VLAN 20, so their SVIs can go up. There are no connected hosts in VLAN 30. However, it has a trunk port, G00, which allows VLAN 30 over it. So, VLAN 30's SVI is up as well. Okay, next rule. The VLAN must not be shut down. Note that this is not the SVI, but the VLAN itself. You can enter VLAN configuration mode and disable the VLAN with the shutdown command. If you do this, the SVI for that VLAN can't become up, up. Note that I think you can't do this command in Packet Tracer, so you'll need a real Cisco switch if you want to try this one out. Finally, if the SVI itself is shut down, it obviously won't be up, up, so make sure to use the no shutdown command after you create an SVI, because they are shut down by default. I used the show IP route command again, and you can see connected and local routes have been added to the route table for the SVIs we created, all shown as directly connected to the SVI for each VLAN. Okay, so our configurations are all done. The next video will be a practice lab, so you can get some hands-on practice doing these configurations. If you have trouble remembering the commands, I highly recommend doing practice labs, and doing them multiple times until you feel confident. So, if one of our PCs wants to reach a destination outside of the LAN, it will be sent to switch 2, which will send it to R1, which will take care of it from there. Note that we didn't actually configure any routes on R1 in this lab. I'm just focusing on inter-VLAN routing at this point. If one of our PCs wants to reach a destination in the LAN, but in a different subnet in VLAN, switch 2 will do the inter-VLAN routing, without having to send the traffic to R1. Okay, before moving on to the quiz, let's review what we covered in today's video. I showed you two ways of configuring the native VLAN on a router. Usually, it's best to just set the native VLAN to an unused VLAN, but if you want to use the native VLAN feature, you should know how to configure it on a router. We looked at some Wireshark captures, both the .1q tagged frame, and one that was untagged because it was in the native VLAN. Finally, I showed you the final method of inter-VLAN routing, using a type of switch I hadn't talked about before, a layer 3 switch, also known as a multi-layer switch. By configuring SVIs, switch virtual interfaces, on a multi-layer switch, you can route between subnets and VLANs, without having to send the traffic to a router. It's like having a mini router within the switch. These last two topics, DTP and VTP, will be left for the next lecture video. Let's move on to today's quiz. As I mentioned at the beginning of the video, I'm happy to announce that, after my usual quiz, a few simple questions to help you review what we've learned, I will be featuring one question from Boson's ExSim, which is a fantastic set of practice exams for the CCNA. I used Boson ExSim for my CCNA and CCNP, and I really think they were what allowed me to pass all of my exams on the first try. If you want to pick up a copy of ExSim, check the link in the description. Let's go on to question 1 of today's quiz. Which two answers are valid options to configure the native VLAN on a router in an ROAS configuration? Select 2. Each answer is a complete solution. Instead of reading out each answer, I'll just let you take a look at each set of commands. Here we go. A, B, C, and D. Pause the video to think about your answer. And remember, there are 2 valid options, so select 2. The answer is B and C. B uses the encapsulation.1q native command on the sub interface. This is one option for configuring the native VLAN on a router. The other option is C, to simply configure the IP address on the physical interface, rather than the sub interface. In that case, you do not need the encapsulation.1q command. Okay, let's go to question 2. You create an SVI for VLAN 225 on switch 1, assign an IP address, and enable it with no shutdown, but the interface remains down, down. Which 2 options might be causing this? Select 2. A. VLAN 225 doesn't exist on the switch. B. You didn't issue the switchport mode trunk command on VLAN 225's SVI. C. You didn't issue the switchport access VLAN 225 command on VLAN 225's SVI. Or D. No interfaces in VLAN 225 are up. Pause the video to think about your answer. The answer is A and D. In order for an SVI to be up, the VLAN must exist on the switch, and it must have either an access interface in the VLAN that is up, or a trunk interface that allows the VLAN that is up. You don't need to issue the switchport mode trunk or switchport access VLAN commands. Let's go to question 3, which will be the last quiz question before we take a look at a sample question from Boson ExSim for CCNA. Which command is used to configure a switch interface as a routed port? A. No switch port. B. IP address, followed by the IP address and subnet mask. C. IP routing. Or D. Switchport mode route. Pause the video to think about your answer. The answer is A. No switch port. This configures the interface as a routed port, and allows you to configure an IP address on the interface. C, IP routing, is used to enable IP routing on the switch, but it doesn't set an individual interface as a routed port. Let's go on to today's Boson ExSim practice question. You issue the following commands on a Catalyst 2950 switch. Configure terminal, interface fast Ethernet 07, switchport trunk encapsulation.1q, switchport mode trunk, switchport trunk native VLAN 44. Which of the following statements is true regarding VLAN traffic when it is sent over port fast Ethernet 07? Select the best answer. Okay, let's check each option. A. VLAN 1 traffic will be untagged. B. VLAN 44 traffic will be untagged. C. All VLAN traffic will be tagged. Or D. All VLAN traffic will be untagged. Please pause the video to think about your answer. Okay, so I think the correct answer is B, because you issued the switchport trunk native VLAN 44 command. Traffic in the native VLAN will not be tagged when it is sent over a trunk interface. So, I think VLAN 44 traffic will be untagged. Let's check. Click Show Answer down here. And as you can see, B is in fact the correct answer. Let's check out Boson's explanation a little bit. Traffic from VLAN 44 will be untagged when it is sent over port fast Ethernet 07. VLAN 44 traffic is untagged because it has been configured as the native VLAN by the switchport trunk native VLAN 44 command. By default, the native VLAN is VLAN 1. So by default, A would be the correct answer, but we changed it to 44. You can issue the switchport trunk native VLAN VLAN ID command to change the native VLAN. Okay, here are explanations for why the incorrect options are incorrect. It also says you can issue the show interfaces trunk command to display the list of ports that are configured for trunking, the native VLAN for each port, and list of currently allowed VLANs for each trunk port. And here's an example down here, after we have changed the native VLAN to 44. Okay, there are also references here to Cisco's official cert guide. This is Volume 1, Chapter 8, about Ethernet virtual LANs, VLANs, and some Cisco documentation. I will leave links to these in the description of the video, so if you want some further reading about VLAN trunks, .1q, please check those links in the description for further reading. Okay, so that's all for today's Boson ExSim practice question. If you want to get a copy of Boson ExSim, and I highly recommend you do, they are fantastic practice exams, please follow the link in the video description. As usual, there will be supplementary materials for this video. There will be a review flashcard deck to use with the software Anki. Download the deck from the link in the description. There will also be a packet tracer practice lab to help you practice the configurations from this video. That will be in a separate video. Before finishing this video, I want to give a shout out to all of my JCNP level channel members. Thank you to C Mode, Johan, and then I'm sorry, but the next person displays only as channel failed to load. If this is you, please let me know and I will try to ask YouTube to fix it. Okay, continuing on, thank you to Mark, Alexa, Miguel, Yusuf, Samil, Boson Software, the creators of ExSim, CD, Magrathia, Devin, Charlesetta, Lito, Jonathan, Mike, Alexander, and Vance. Sorry if I pronounced your name wrong, but thank you so much for your support. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.